Hello, hello. Welcome everybody. So, let's look at some ICs. There are quite a few that I'm interested in. First of all, I'm doing fine, thanks. What about you? Okay, so the first one is the Type B, which is a 60% HHKB. These are the layout options. So basically, it uses the same HHKB layout as the true HHKB from Real Force and Topher, but it adds ISO without being JIS, which is kind of based for those people that actually care about ISO but don't want necessarily the extra keys by comparison. Oh, let's look at this. Hypro. So the JIS HHKB actually adds quite a few more keys than the standard ISO, mainly because of the need for dedicated Kana and select key for the input system. So we have a fuck ton load of extra keys. Arrow cluster, which in my opinion is actually pretty base, especially for those of you that might not like the standard arrow placement in the HHKB. So I personally really like it. Most of people though don't really like the fact that the right shifter is shorter than the standard HHKB, which is already a split right shift to accommodate the FN key. So it is what it is. I personally really like it. And we have the standard HHKB split configuration as well as the ISO configuration. So that's pretty neat. Optional gummy strip mounting seems pretty good in my opinion. I don't know which hardness level will be offered, and I'm not sure it's even mentioned. I think it's not mentioned anywhere. Yeah. But I mean, you can always buy replacements if you really want a different typing experience. So it is what it is. The weight is very interesting. I really like the fact that it's not a slimmer weight to accommodate for all the daughterboards and USB hub. So yeah. Oh, hi Hankit, hi everyone. The question was which hardness the gummy strip will be, because I don't see it mentioned anywhere. So I think it's gonna be clarified later, or maybe Paul will do some research in the IC. Oh, okay. Then it's gonna be a later thing. So coming back to the weight, as I was saying, I really like the fact that it is not a slimmer and smaller weight, just because there are so many boards underneath it, but instead there are actually properly sized cutouts so that nothing gets squished. The JST seems to be pretty standard and quite long, so there's not going to be any problem with trying to hold the top case assembly while plugging it in. The USB hub is very based, and the finish is fantastic. This is an insta buy. Let's see what else we have. Another TKO. Okay. Unique mounting style. Huh. Oh, okay. So basically, it uses the same concept as the doll, but instead of using the O-ring on the PCB, it's used on the plate. Okay. Huh. Interesting. Any price? USD. Normal edition, 475. Haha, nice one, Pontus. Nice one, Pontus. I was not expecting that at all. Okay, so 475. What's included? Okay, aluminum top and bottom, 7U. No ISO. Oh, Ponto's gonna be sad. Sandblasted, brass front badge. Okay, whatever. Unified daughterboard. Alright. Custom silicon fit. Screw hardware. Okay. Extras. Okay, so the usual. No. Avoid spamming in Simon code, please. This is a totally one-off thing. Okay, now we look at HandKit's stuff. Why is it taking so long to load the images? Okay. Very based. Layout is based. I really like it. Yeah, the pictures are a bit too high res, maybe. Nepipi hair? No. Hmm. I was expecting a PP hair. Why is the right control on the render darker? Oh yeah, it is darker. Haha. Skill issue, I guess? Yeah, I think it's a skill issue, you know? Yeah, okay, we'll count the darker control key as the PP hair. It's nice. It's a nice addition, you know? Why there are two controls stacked? I think it's just to show the bottom row options without leaving the empty spots. So, for example, here, the super key is repeated, but it serves the same purpose. So, that's why I think. Back, okay. No BS. The price is very nice, and the fact that all the proceeds by the project will be donated to the local food bank is also very based. A very nice decision by Hankett. Let's move on. Oh, I see touchpad. Oh, this is my shit. Okay, so it uses a circular touchpad. Okay, I've seen a couple of prototypes, not of this board specifically, but on the QNK Discord server about circular touchpads, and I really like them. I'm not sure about the like the granularity of control, if it's decent enough for me, because I used to have a trackball, like a mini trackball. I can actually show that. This one. Which actually uses a Pimoroni module. So as you can see, the mouse moves, but the granularity is very low. It's not really because of the software, but rather the hardware implementation. So I really hope that the hardware of this trackpad is better than the one on the Pimoroni. The superior option would be a BlackBerry nipple point, but those are very small, so they're not even bigger than the reset button. So how much is this? Let's see. Okay, so it's 70 USD. It includes PCB, bottom plate, black pill. Okay, black pill and GPIO expander. Oh, okay, so this one is not an Atmega with a virtual USB firmware. Oh yeah, I can see now the under the OLED the black pill footprint. Okay, so black pill, GPIO expander, OLED LEDs, diodes, and all of that. Knobs and encoders. Glide point. assembly hardware. Huh. Okay, this is not a unreasonable price, in my opinion. I don't know how much the module itself is, but given that you have basically every like add-on option already included, I'd say that $70 it's pretty good. Okay, changes plates for MX and chalk. Okay, so now it's plateless only, which is, I mean, fine because chalk uses a 5-pin anyway, so that's not really a problem. Okay, proper chalk spacing. I liked it. Steno support. Okay. I mean, this is pretty good. I'd personally buy it. Yeah. So, let's see what else we have. I'm skipping most of the keycap sets because I really don't like to look at keycap sets, and I usually don't buy them because I'm into Topper, so I usually use the stock caps or buy way overpriced BKE to then transplant the caps onto my HHKB. Okay, BB60. Totally not a funny joke that started at like 3 a.m. because of a certain other 60% more that was going around. But hey, this actually works, so, you know. Consider working PCBs, please. Also, for those of you that maybe are interested in RP2040 PCBs and want the VIA support, because fuck VIA, on the main VIA repo, there is no official RP2040 support, mainly because XYZ decided to include it in Q3, I think. So after the all the RP2040 submodules like EEPROM and all of that are actually fully merged into Q&K, but there is a fork of the VIAL repo that actually is regularly updated. So there is nothing to worry about compared to the, for example, the Gonok repo that was like 6 months old. So if you wanna actually use that, I'll leave a link on my Discord server. Oh, hi Jampot and everyone who joined. Layout options, it's fine. It's not overdone. I like the 10U, not because it's a meme spacebar support, but it's actually based, at least in my opinion. Maybe, and I say maybe, but again, it's debatable on a MX option. A 6U spacebar would have been nice, but again, 6U is kind of dead at this point. It's usually included in very, very overpriced spacebar kits. So it is what it is. Hey, new Ankit, I see. Model M. No, I really think it's my internet connection that is cucking me. Because this is looking way too slow. Come on. Press X in chat to doubt, please. X. VL. Let's go. We should make it a standard to only use QNK/VL and not QNK/VIA. RGB, of course. USB-C interface, gasket mount. Alu construction. Okay. 2 PCBs. Oh, okay. So let's see. Okay, it uses a 2 PCB assembly. I actually design primarily MX PCBs for commission. So yeah, like that was always a thing. It's only that people who actually commissioned me to do MX stuff either disappeared or are still in the process of developing the cases and or complaining to the PCB manufacturer because they fuck up the flashing process. And yeah, Jampot, we're basically wasting time now. We're looking at random ICs just because. Then I'll show maybe a couple of Topher PCBs that I have around and show the R1 project. Oh, I remember this. We actually looked at it on Simon's stream. And I remember about the flimsy ribbon cable, which I think the designer actually clarified was only because he didn't use like a standard protocol at first, because it uses the Lenovo TrackPoint module. So it needed a fuckton of lines instead of like the usual 3.5mm cable. Because when you're working on split keyboards, I've noticed, especially on those that use non-standard modules, as well as custom routines to scan the matrix, The transfer function, which is basically that process in QNK that handles the collection of key status, and it's basically responsible to report that to the main or the master controller, so the one connected to the PC, can be quite tricky because it might be working, like the board works, but after a while, for whatever reason, it stops working or it starts to swap the key configuration. So, for example, if I have the A key on the left, which is the master, and the J key on the right, on one of my prototypes, when I pressed the J key, it actually reported as the A key. So it was a very weird behavior. Alright, time to look at some Topper stuff. Let me turn on some lights. There we go. You know what? I'm gonna take an EC87 PCB and then show the rest. I'll be right back. Alright. So, this is the original EC87 PCB with the THOC min on it. This was my second EC PCB. The first one being the Corn EC. Make it a bit bigger. Yes and no, I can do this, but don't expect high quality, mainly because this is I think it's a 480p webcam. Yeah, skill issue, I know. And the frame rate is completely trash, so, you know. I can pull up the actual GitHub repo, which has way better pictures. So GitHub open. Yeah, I think my internet is cucking me because this is way too slow. Like incredibly slow. Alright, so let's switch back. Make everything 100% louder I guess. How is it now? I've reduced the filtering in OBS. Okay. So this PCB was the second EC PCB that I did. And this was the render, and this is the end result. It's from JLC, mainly because of the low cost. But I gotta say, on 5 PCBs that I ordered, the surface finish was total trash on like 50% of them. And I wouldn't mind it on like an MX board, because again, the surface finish on the MX board is basically useless, I'd say, apart from an aesthetic standpoint. But on the EC PCB, the PCB itself is part of the actuation system. So if I have a scratch on one of the pads, it will actually affect the sensing. You can see you can kind of see it here. There are like marks, and those are not like pencil marks. Those are like scratches, which in this specific point is fine because this is a ground plane, so it's not actually used for the sensing. But here, for example, or here, those markings will actually affect the sensing because the surface will not be even and charges would go all the way all over the place. Yeah, so this is the first TKL. The plates are pretty much standard, nothing crazy about them. The usual note that I put out. Yeah, that's a lot of vias. I overdo on vias on the EC87, especially on the top side. You can see it here. I overdo the vias because I was afraid, frankly speaking. This was a large hit on my wallet at the time, so I wanted it to be as error safe as possible and as noise free as possible. So the purpose of the vias, especially because this was a 2-layer design, so only top and bottom copper. And what I was afraid of was crosstalk and cross induction between traces. So here I definitely overdo the via game for the USB data lines. And on the rest of the PCB itself, I usually place 4 vias where there is a crossing of traces. Ideally, especially on analog and to some extent digital design, you don't want traces to go parallel to each other, because if current flows through one of the traces, then it will create a field that will induce a charge on the other line. But then I realized, especially in the sensing columns, that even if one sensing line induces a charge on the next one, I will not keep track of that because I don't scan all the sense line at the same time, but one by one. So, and after each scan, I clear the board capacitance. So even if there is to some extent the cross inductance of charges, it's not really a problem for how I designed the scan routine, but since I don't want to do things improperly, I tried to keep correct spacing, and if crosses are needed or unavoidable, to cross in a perpendicular way, so like this. So this is bad, this is okay. So that's why I have a bazillion of these. How did I start learning about Topre? So I bought a corn a long while ago, and after that I saw Gonok's EC corn. Corn, I think it was called ECWL. Autocorrect, nice. Yeah, this one. Which is basically was a corn, but wireless and EC. But the thing is, it was out of stock everywhere because, as usual with Japanese designers, they do cool stuff like this. They do a very low quantity run and only on booth, and they didn't offer international shipping at the time. So if you wanted it, you had to use stuff like Bai, which is basically partnered with both, or Sandico with a custom order. So yeah, the main reason was that I thought it was cool that it was Topre, but again, I couldn't buy one. So I looked at some Reddit posts, and I actually found, I think I have a link somewhere. There should be a link somewhere, or it's in my Notion page. There was someone in the US, I think it was. Oh, nice. GG. Let me grab the link in another way. There we go. So I basically found this Reddit post about someone trying to basically sell all of its weird boards, and I saw the corn, but it was like $300. All the topper parts were included. Those are NATE's housings and stem, and the domes, I think they were basically transplanted from this NATE dome sheet. So again, it wasn't strictly speaking real OEM topper, but the function was basically the same. It was easy, so I wouldn't mind paying for NATE stuff. But yeah, the problem was that the price was astronomical. So I said to myself, what about a reverse engineering of the corn, and then from that do a PCB run? So that's what I did. I firstly studied the Topper patent, which is kinda dead slash kinda pending slash expired. It's weird stuff. US patent system is very weird. So they basically gave a rough explanation about how the design of the switch is and the detection system. So I developed a sensing circuit, which is based on the custom EC design guide by Tom on GitHub, which is kind of old. It's 6 years old, but if it's working, why change it? One thing that I changed is the topper pad. Bye, Ash. So here it basically gives you a rough explanation on what is happening on Topper. And from there, I started designing a PCB for it. Which, in the first revision, the idea was to basically have it one-to-one compatible with the Gonox board. So it used a non-standard mounting points. But then I realized that adding the standard mounting points of the standard MX Corn wouldn't hurt performance nor increase design complexity. So what I did was release basically two revisions of the same PCB. One for the ECWL Sol Gonox version, and the other with the standard core mounting. That way, if someone wanted to use the PCB with all the accessories already available for the corn, they could just take the design files, go to JLC, order PCB, and basically have a Topper corn. There's also a a build guide with parts and all of that. And this was the actual PCB. This is all hand soldered. So yeah, that's how I started designing Topper stuff. After that, people started complaining about not liking the corn. So I said, okay, I can do a TKL then. My first idea was to basically copycat the Real Force R2 PCB, because someone, Lysol wink, was doing a Real Force R2 case. So I wanted to basically have a ready to go PCB to basically use it on that case. But then I realized that the spacing between the clusters, especially the F-row and the Aero cluster, wasn't H87 compatible. So I said, okay, what I can do is basically use the H87 spacing and basically have an EC H87 spaced PCB, but that was not H87 compatible. So the outline was different. Mounting points, of course, were different. So the only H87 thing inherited was the spacing and the layout. So this was my second EC project. It was fully FR4, not the best nor the smartest idea of mine, because the way Topre, especially real forces, is quite clear in real force boards, the assembly. You basically have the PCB, the housings, domes, and all of that, and on top of that, a metal plate where the holes are threaded. So you basically have screws. Let's see if I can. You basically have screws that go through the PCB from the back of the PCB all the way to the plate, and then they screw to the plate. And one of the reason, it's the main reason why real force boards use so many screws is because even if you have a metal plate, it's not completely flat, nor the FR4 is completely flat. So you will have air gaps in some places, especially in the middle. And that is not good for multiple reasons. First of all, if there is free space, the dome will basically have a null pre-travel where you basically press with the plunger on the top of the dome. It will go down a bit up until the dome sheet touches the PCB, and then it will start the dome travel. So that's one thing. Another one is that the topper springs are not clipped in. They're not self-contained. So they will basically move around. And that will cause all sorts of problems with spring noise, spring crunch, bad detection, because maybe the spring shifts from one key press to the other. So that's why there are so many screw holes. So yeah, this was the EC87, a working prototype, a very good proof of concept in my opinion, because that allowed me to develop all the coding in QNK and later in VL to actually have basically every EC PCB that I'm doing VL compatible. After this came the meme, which is basically, I'm not even afraid to say that because everybody knows about it by now, a copycat of ISO. This is ISO Topre, and it's no more, no less than an ISO compatible PCB, but EC and with RGB. So that's it. I can actually test it, and I have two. So if someone at the UK meetup wants one, you know, wink. Yeah, so this is a modified version of the original ISO case to use a 1.2 millimeter plate. This is a 3D printed plate, just a proof of concept. And I have both a NIDS and a OG Topre plate available. But then I realized that since the distance between the PCB and the plate on Topre is larger than on MX, the entire assembly would not fit inside of a OG ISO case. So what I did was to basically, let me grab a link, was to basically reduce wherever possible thickness so that it will actually fit inside of the original ISO case. So this is the PCB. The LED is not populated in the bill of material, mainly because from JLC the LED availability is total trash lately, and maybe someone doesn't want the LED cost or the LED altogether, so it can be easily soldered. It's a standard SK6812 LED, so it's quite easy to hand solder even. This is the Topre 2U plate, and this is a somewhat working plate mount MX compatible stab. Mind you that since the Topre underneath housings are larger than the MX counterpart, you'll need a modified wire, or you can grab the files and use a co-star option, which is totally fine. This is the prototype, and I'm waiting for Mr. Cac Alessio to actually verify for me that the newly produced PCBs actually fit inside of the original ISO case, because if that's the case, then I'll probably do a small private group buy for a limited number of PCBs to bring with me to the UK meetup, so that way we can save on shipping for such a small item. High quality pictures. This is the newly designed PCB. The PCB itself is now 1.2 millimeter, and the plate is 0.6 millimeter. It's not really a problem that the plate is so thin, because its only purpose is to basically have a clamping. It's only used to clamp down the housing to the PCB and nothing more. So after the ISO happened, the idea was to have a Topper numpad developed. I actually have the PCB basically done, but the PCB to PCB connector that I wanted to use is basically out of stock everywhere, and without it I cannot guarantee that it will actually fit in basically the original case and whatever custom case that people will develop. Now we can probably show this. Yeah, we can show this because it's already out there. So next up, there is another TKL, which is, let me do a bit of PR spamming, since I actually want this board to actually do well. Geek hack. Wait, it's probably better to grab the link directly from the server. Yeah. Let's see if I have a proper link to this. So this PCB is kind of based on the EC87, but it was actually a test run for the next iteration of the EC87 and basically every other EC that I designed after that, because this is the first one that implemented the first one that I made, not the first one ever. I gotta point out that basically supported multi-layout. The multi-layout is very limited on this one. It basically has stepped caps lock, okay, stepped caps lock and the normal caps, as well as 6.25 bottom row and 7U bottom row, and the spacing is standard H87 and all of that. And this turned out actually pretty fucking good. I had initially some problems with the detection on some of the merged pads, but after some tuning in the firmware, they were basically one-to-one matching to the rest of the board. So this was a very interesting OCD. Silkscreen art on the back, very based. This was actually a very successful prototype run. The number of mounting points is reduced compared to the EC87, mainly because I wanted to replicate the real force spacing, because hey, if Toparade does that, it might be good. For sure better than mine. Yeah, the silkscreen on this was made by JLC. Mind you that we used the standard assembly. I don't know if there is a difference in the silkscreen between the economical assembly and the standard assembly. Now JLC actually offers two different types of silkscreen option. One that is, I think it's called like laser focused or something like that, which is highly clear in the text. Let's see, instant quote. I gotta add some random stuff. Board. Let me find a random. Okay, let's try with this. So they have now two options for the silkscreen. I didn't try the new option yet. Oh, there it is. Silkscreen technology. One is inkjet and the other one is high definition exposure. And you can actually see the advantage and disadvantages of every option. I mean, if you're not using super fine printing, the one that they offered previously is totally fine. I don't know if you can clearly see it. But yeah, no way. Like the small text near the multi-layout options is basically crisp AF. Even like complex letter, like the E, A, Y, for example, are very clear. So I don't really see the point in spending more in the high exposure unless you actually want the crispest of C screen, which at that point I might point out that going with JLC is not the best option because they can fuck up stuff like pretty easily. And the prices are okay if you go on larger volumes, but JLC is good only if you need like a very low quantity option, like for cheaper prototypes, or if you need somewhat in range of like 5 prototype PCB at maximum. If you, for example, choose 2 assembled PCBs on the 5 PCB minimum order, the return on investment is completely garbage, because you'll end up paying way too much for the assembly that cannot be diluted on the entire batch. So one PCB ends up costing like $50, which is complete nonsense, especially if you want to then sell that PCB to someone. So yeah. So this was a very successful prototype. After that, I wanted to do the funny, mainly because of Gempot, I gotta say. They basically wanted me to include ISO, but I didn't want to spend the same amount of money that I did on the EC87 to test basically the bazillion of layout options that bottom row and ISO basically carries with them. So I decided to do a 60%, which is still a usable layout, I'd say. But again, I encountered the problem of which which outline to choose, because on the EC87 I had this problem that is not solvable of having to enlarge the de facto standard PCB, for example H87, because otherwise the housings will not sit in the PCB, and that is a problem, especially when on the edges you don't have supporting screws, because again FR4 is not completely straight. Plates being out of plastic, metal, titanium, whatever, they are straight up until a point, and especially after you introduce a buckling compression factor with basically compression all over the board except the edges, it will inevitably warp. So if this is the plate, this is the PCB, and in the middle there's the housing, you basically always end up with somewhat of a crooked angle, and that is not good on the edges because again the dome sheet will not be properly compressed and all the problems that I mentioned before. So 60% is a decent layout option because at this size the buckling doesn't cause that much warp in the edges, and I don't need a custom made super weird edge screw to counteract that. And luckily I noticed that the GH60 standard was actually pretty good for this. The domes are fully compressed, the housings sits basically flush with the edge of the PCB, so this is basically the minimum dimension for 60% on the GH60 form factor. the layout options that I wanted to include in this PCB were as much as fucking possible. uh, because again, I said to myself, okay, I need to basically run a prototype to test the multi-layout option, and if I gotta test multi-layout, it better be multi-layout for real. So I included everything. Let me show you the final layout options. Again, grabbing my images on the Discord server. Again, super high quality pictures from Discord compression. GG. So, for those of you that are into the Japanese keyboard scene, you'll probably recognize this layout. This is the JP60 layout, which ironically is by Gonok, old friend back again. And it's basically a somewhat JIS compatible 60%. So what I wanted to include was the three main layouts, so JIS, ISO, and ANSI. Then an opportunity came to adapt this PCB to work with an existing keyboard that uses HHKB through HHKB, so 6U, and a split spacebar, so double 3U. So I tried to include as many options as possible. So split backspaces, stepped caps lock, and basically everything that you can split is splitted. Being EC, I wanted to have the JIS layout to be compatible with the RealForce 91U configuration, because the ISO project started as a meme and then turned out into an even bigger meme, where I wanted to be basically a safe home for all the ISO enter that are now borderless because people harvest my precious 91U. Stop harvesting, please. So I wanted to be able to use every keycap from the RealForce board. So that's why I used the RealForce layout option. And the rest is the standard. So this is the blank PCB. I've silk screened on the PCB again my high quality webcam can't really show that, but there is basically markings telling, for example, on the backspace, the middle one is the unified backspace, then there is 1U, on the right shift, which was a hell of a job to make it work. There's 1U, 1.7, unified, 1.7, then 1U again. So this was actually a very successful prototype run. I have an FR4 only because I'm super cheap and I only work with the PCB, not the case design. I really hope that now that more layout options and more form factors are available, people will basically contemplate EC options from the beginning and not as an afterthought, or because someone said, hey, could you please add EC option to this board? Because there are all sorts of problems with clearances and such So this is a very hacked up EC60 in a HHKB. Yeah, so Ankit, the Vero Topper kit is not cancelled. I designed the plate to use the standard HHKB 6U Topper spacebar stabs, but we noticed afterwards that, I don't know if you remember it, but the OEM Topper stabs are even larger than the Topper housing itself. It sticks out from, if you take the side of the bottom row housing, it sticks out 3 millimeters, because again, the wire needs to sit further away. Yeah, 3 millimeters. So I also told you about the housing problem. So if you use the split 3U option, there are absolutely no problems whatsoever, because for every stabilized key in Topper that isn't a 6U and above spacebar, the 2U housing is used, and that implies that there are no stabs, because the stabs is basically integrated inside of the housing. So the options that we're exploring now for the spacebar are either use MX plate mount with a wobbly wiggly wire, which is basically a MX, like a standard MX Cherry MX plate mount, but the wire, instead of being straight in the middle where the housing would be, it basically forms a lip to go around the housing, and we need to actually check if even the wire thickness introduces problems, because if, for example, we have, let's say, 2 millimeter clearance between the housing and the case, but the wire is, for example, 1.6, I think it's 1.6 on Cherry, we gotta be careful that the wire is perfectly straight, and that when it's moving, it doesn't basically move around, because effectively now we have 0.4 divided by 2 millimeter of clearance between the housing and the case. So we gotta check if that's a viable option, or use CoStar. I really think that CoStar on MX is meh. It's meh because there are way better options, but on Topper it's not that bad, mainly because the key are so well stabilized by themselves that it's fine. It's fine. Like, if Nate can get away with it, why can't I? You know? And that will ensure that no harvest is needed. Another option is use the Real Force RGB stabs, which are kind of plate mount, but are inverted plate mount. So MX plate mount, you basically place the stab from the top of the plate. Real Force RGB stabs are inserted from the bottom, and they're kind of weird because they use an offsetted stem. So for example, in your standard MX, you'll have, let's say this is the, I think I actually have. I think I have somewhere. Yeah, there it is. So this is A2U, but it's the same. So on MX, you have the stem right in the middle. In the Real Force RGB, instead, other than the stab is basically put from under the plate. The stem is not centered, but it's offsetted by I think it was 2.2 millimeters inwards. But again, I didn't saw even on Alibaba or AliExpress vendors actually selling aftermarket spacebar kits. So you'll need to harvest, and I don't want people to harvest. I'd rather prefer people to use split, like force to split 3U spacebar, rather than having to buy in 100 and whatever to operate a real force, just to harvest the spacebar steps, which is not even the correct one, because real force RGB doesn't use a 6U spacebar, so you'll need a custom wire anyway. So there's really no point in harvesting. Do you know if there are desk replacements for topper style steps except with MX stem? Yeah, they actually have that. Oh yeah, test run. This is a very janked prototype. It only has JST, and my fantastic electrical taped daughterboard is not a unified daughterboard, but it's instead a Pro Micro with date at Mega, on which I basically hand soldered the JST cable. So I effectively hijacked my Pro Micro. Because I bricked it, I set it the wrong fuse values, and now it's bricked forever. So let's switch to... Okay, so they have wires 6.2, 7, and 6, finally 6. And they have a stabilizer pack, which includes the 2U and the spacebar. And the spacebar actually... I don't know if you can see that, but those are MX stems. And those that are sold now are the retooled one. I'm not sure it's strictly speaking a retool. You should ask... let me see if I can find his name. He's a fellow Falker. Anachronism, he's called. He's a Scottish fellow Falker that actually streams on Twitch. And he basically was in contact with Des because 2 MT3 sets had cracked keycap stem because of the wrongly sized stem, but now it should be solved. So if you buy Des housings, stabilizer housing, now they're fine TM. Oh yeah, they actually now published pictures of the volcano spring, which funnily enough, I'm not sure this is a copycat or not. These are very reminiscent of the handmade springs that Gonok made for the newly released and improved Korn EC, now based on RP2040. Yeah, so he basically decided to randomly include handmade springs for whatever reason, and they are basically the same. Tolerances, I bet that on the Des springs are better, but yeah. But hey, if you wait a bit, Pop can maybe give some time window for that. You can have conical springs for a bit less than $25. Wink. Yeah, so anyway, the layout options on this board are basically everything that can be fit in this whip. Whips out, Pop Smoke, whips out. So as I was saying, the layout options on this PCB are literally every fucking layout that I can think of, except 6.25 because fuck the normie bottom row. And also I had problems merging paths between the various layouts. And as you can see, it's VL compatible, and you can choose basically every config. The cluster changes from JIS/ISO to ANSI, then the bottom row configs are the JIS, the real force one, to the true HHKB, real force 6U, and a 7U. So yeah, this was a very fun project. I didn't manage to source the correct USB ports for the reference design EC60. So this is the modified version for Vero, which only uses JST, but it's basically the same. The only thing that I changed from the reference design to this one is the outline, the placement of the JST, and the removal of the USB port. So that's the kind of ease of use that I want to include in the EC series. Basically a drop-in for those of you that maybe just want to try the PCB and don't want to spend a lot of money on like alu cases. You can take this PCB and using the standard GH60 mounting points, mounted in a $50 clear case from AliExpress, or you can develop an entire ecosystem around it. For example, the Vero PCB. So yeah, this is basically mission accomplished for the EC60. Now that I have confirmation that the bazillion of layout options are not a problem for the detection system that I'm using, I can now focus on hi Fluff. I can now focus on having an equivalent TKL version. It will not be called EC87. In fact, I'll probably not basically market it as the second revision of the EC87. I'll probably later this week or next week, if I don't have time this week, basically point this out in the EC87 repo. But I'm thinking about changing name completely to have it basically be a full-fledged whatever layout you can think of TKL. The spacing of the keys will be HED7 based again, because that's what people like and are used to. And I'll try to make it already in the smallest PCB edge cuts as possible, because for example, the ECD7 was very oversized, and I had to do basically a step model for people to actually see the minimum dimensions. But I think that if I provide a already minimum dimension, people can only scale up from that. Yeah, so that's the main goal now. And one step that is helping me to achieve that is the let's roll whoever decided that a RealForce R1 PCB should cost $70 for a PCB only, mind you, PCB only, from China. So, you know, it's from China. Nothing wrong about buying from China. Every PCB is basically from China, and I'm not implying that China stuff is cheap, but you know, like it's common knowledge, I'd say, that stuff from China, especially Topper, you can actually find pretty cheap Topper stuff. Like, for example, I found one day an entire RealForce R2 with the variable actuation point PCB on Taobao for like $25, the PCB and the case. So I bet that whoever is selling that basically just bought it for the harvest part. But again, $25 for the case, the plate even, and the PCB it's basically a steal. Even if you buy all that stuff, you're not going to pay more in the end than a new in-box RealForce R2. So yeah, so I basically decided to export the EC60 stuff, so multi-layout and all of that, to the RealForce R1 PCB. And this is actually very based because the top lip offers so much real estate. It's free PCB estate, you know, for whatever I want. I can trace out stuff with more clearance between one trace and the other. I can use one side for memes. I'm planning, for example, to use a RGB header, so you can basically stick RGB strips on the back. Because again, if maybe someone wants to spend 1K on Norby housings, PC, or whatever housing they can find, and they want RGB, now they can. I'm not sure if I can add RGB on the top two without basically creating an entire EMI problem with the RGB strip, but it's an option. And since I've looked at OGR very closely, I decided to include again every possible connection method that you can think of. So here we have the original RealForce connector, which is a JST connector but with a 1mm distancing between every pin. Then, so you can use the original cable. So if you use this, the use case would be, okay, I bought a RealForce whatever, 91U, 86U, whatever, and I want it to be VR compatible and do whatever I want with it. So you get this PCB, you use the original wire, and you're good. Another option is the standard keyboard JST. This is intended for people who might want to do a custom RealForce R1 inspired case and want the JST option, but maybe they don't want to use the big ass JST one. Another option, since we have this big empty space here, is USB-C. So you can have, maybe you have custom cables like this one. This is a 20 centimeter long from one end to the quick disconnect, so it's larger than the usual measure. So you can actually route this inside of the keyboard and basically have the quick disconnect come out. So it's kind of the same approach as some of the OG big ass keyboards, where they basically use integrated cable with quick disconnect, but instead of soldering, you can use one of your pre-existing cables. An example might be this one. So I have a Real Force 91U. This is my test board for taking measurements and all kind of stuff. So we can actually see if we take the top off and the plate. One thing to notice is that on the original plates they have a protrusion with a screw. This is a grounding screw. And if you look at my PCB design, the original JST for starters is not on the left as in the original Real Force boards, but is on the right and is centered, so it's not on the edge. And this is because of this grounding pin. And there is no problem in having the JST in the middle of the board, because the JST is actually raised. I don't know if you can yeah, you probably can. Yeah, you can kind of see it. It has plastic between like where the connector goes and the PCB itself. So it's not like you're rubbing the connector on the PCB itself. But again, even if that was the case, you're not basically plugging it in and unplugging it like a USB connector, so it's not a big deal. So yeah, the inclusion of the USB-C is to basically mimic the OGR approach, where you have a longer custom cable. There is actually plenty of space in the Real Force case, especially in the 91U. Some other cases, especially the full size, don't have the middle routing channel, but only the side channel. So if you were to use the USB, I'd say don't, if your board case only has the side channels, because the length that the wire needs to be is quite large. But instead, if you have a centered channel like on this one, you can simply, let's see if I can unplug the ferrite bead. There we go. How many topper boards do I have? Way too many. Let's just say that the Sony BKE, the big ass one, is sitting on the other edge of my table, and the MKS, the little one, is on top of my printer. So that's how many topper boards I have. So yeah, this is the inside. You can't really see much. Let's see if using a light. Yeah. So you have a center channel. Yeah, clearly I don't have enough topper boards. I actually have a couple of boards stuck in Japan, mainly because of my skill issue, because I thought that I could just go there and grab them, but clearly I can't given COVID. So yeah, big skill issue on my part. So the idea is you basically snug the your custom USB cable, given that there is enough space for it. So maybe some tweaking is needed. Let's see. They should be able to just press it. Yeah, I mean, you get the point. Maybe you need to clip off the two little plastic bits here. Let's see if I can stick the light. Okay, yeah, poggers. Okay, so these two. If you clip off those two, you're good. You're good. So yeah, this is the PCB. The USB connector is here. The concept is the custom cable goes under. The PCB is on top. The quick disconnect is outside of the case, and you basically have the USB plugging right in here. I don't know if people are actually gonna use that, but it's an option. I'd prefer giving the option than not giving it. There is plenty of space in the PCB because here it's basically empty as well as here. So this part of the PCB will be basically just an extension of the USB lines. Managing proper data line integrity might be a pain because I'd probably have to choose from the JST and the USB port which one to prioritize. By prioritize, I mean the data lines will be on the top side. So from which connector to keep the data lines always on the top side, and on which one instead bringing them to the under like on the other side of the PCB, because they're not mirrored, they're matching. So there's that. I don't think for this project I'm gonna do oh, nice. Then let's hook up a ISO. I don't think I'm gonna offer plates nor plate file for what it matters, mainly because there are already like people sell and make real force plates already. Designs are out there, and the idea behind this PCB is to be a drop-in replacement for your existing topper board, or If you, for example, buy a 91U and you want to convert it to whatever layout you want to use. So yeah, like that is the intention and the motive behind this project. So there is really no point for me to actually make plates, especially since they are already available. One problem that is not really a problem, it's more of a consequence of the multi-layout nature of this design, is that, okay, for starters, I have to include way more mounting point holes than on a standard PCB. For example, if I take the GIS PCB, some of the mounting holes that are marked with the usual arrows in topper boards are not present, but on this design they are. So for example, here you can see that the second switch, between the second and the third switch on the bottom row, there's a hole. But if you look at the JIS PCB, you don't have that. You only have the one on the extreme edge and one after the third. And even there, here there's a hole precisely in the middle of the third and fourth. But on this design, you can see there is the one that I mentioned and an extra one. So what is up with that? What's going on is that the Real Force series, the R1, used, of course, different mounting points based on the layout option. So another thing is on JIS, you have a mounting point between the backspace and the yen key, which are the split backspace keys. On the whatever Real Force R1, not JIS, that you use, where there's a hole in the JIS one, there's an EC pad for the non-split. So of course, here I have the non-split, here the split, and of course the middle hole is missing. Another thing that you can notice is this extra hole. This is for the 2U on the non-split one. There are other instances of weird placements. For example, here, the hole actually cuts part of the pad, and I'm debating if I actually want to even include this mounting hole or delete it altogether. And the same goes for this one, because I could use a modified footprint. For example, in the left shift, instead of designing a three-way pad like this one, where I have 1, 2, 3, and 4 separate channels. Here I did a bit of dark magic where this center pad is basically the same as the right one. So the right one is row 1, column 14. The middle one is again row 1, column 14. But on other designs, for example in the EC60, I had to basically split every pad section in its own channel, because otherwise the keys will be merged in Q&K. So one thing that I can do is design a pad that is not complete, but it's instead cut. So for example, we go like this, mirror. Okay, and you can see that now I have enough clearance between the two pads to be confident that they don't touch each other, even if the manufacturer of the PCB is not 100% the best one. This is a 0.4 millimeter gap, which is usually the double the minimum spacing distance between traces, which is a 0.2 millimeter spacing. This is the standard one, so if I am above that, I'm Gucci. So this is basically where I'm at now. I had to do a bit of dark magic again, especially on the nav cluster and modifiers. I'm not even sure they're called modifiers. Like home, insert, and delete, that kind of stuff. To actually avoid using more than 2 multiplexers, I'm not using the same circuit for multiple reasons as the real force one. The main one is because I'm afraid of copyright infringement, and we all know that Japanese companies don't like when people do stuff based on their designs, nor stream about it. I'm talking about a certain video game company based in Japan, but that culture is quite spread across corporations in Japan. So if I can avoid even remotely talking about copyrighted stuff, that's for the better. So yeah, I basically had to pull some dark magic wiring, which is totally nonsensical compared to the very linear matrix style on the rest of the board, to avoid using an extra multiplexer just to keep the oh well, it's all nice and grid-like layout. So for example, column 13 goes from this key all the way to the split backspace left key, then down to the ANSI reverse slash, then the ANSI enter, and so on. Column 14 is weird as well, because the column now are on the same row. And same goes for column 15. I have a cluster here. But the important thing is in the matrix, they need to be different, and in some cases they need to be the same but doubled. For example, here I have these two switches that are the same matrix wise. They're both column 6 row 5, and that's because even if they are different keys in different layout options, they share the same function. For example, this is the spacebar. There are cases where the key will have the same matrix position. For example, in the left, in the left shift, I have a shared matrix position for the unified left shift and the 1.25. And some of you might say, oh well, yeah, like this is shift and this is shift, no matter the layout. Yes and no, because I can choose to use this key for whatever. I can swap the weird whatever key the ISO users use for the 1U key here to be here and place the shift here. So the important thing is to have separation where it's strictly needed. Another example might be here. I could avoid using separate key positions for the ANSI enter and the ISO hashtag sign. But since I have space, I decided to share the row, which is fine. They're on the same row, but use separate columns. One thing that cannot be avoided, and this is the weird part about EC paths merging into each other, is that, for example, the ANSI backslash is totally not the same as the ISO enter. But given how the switches sit, they inevitably merge. So I need to share the row, but have a way to distinct them. So here I have column 13 and here column 14. Weird stuff starts to happen if I do a more complex design. Let's see if I have the EC60 here with me. I can always clone it. Okay, we are cloning the repo. Let's save this. And of course, the EC60 will be open sourced in the future. By future, I mean less than a month. Mainly because I want to further test some of the features. Okay, so this is the PCB for EC60. And we can probably do this. Okay. So as you can see, here I have the same situation. Imagine unironically using ISO. Yeah, ask Pontus. Here I had a lot of problems determining the sequence of connections because I had to maintain the separation between the paths. I can't do the same thing as here, where the unified backspace is row 0 column 14 and the 1U is again row 0 and column 14, because when I assign matrix positions in the wiring, that will affect how the VL software, or Q&K in general, will treat every key position. So if I want to keep the keys as separate entities, even though in the actual layout they serve the same function, I need them to be separate. And especially here, where I have the option of a unified right shift, so right shift here, or the double split right shift options for HHKB and ISO. The weird thing is that the shift swaps position on the ISO config and the HHKB config. So in the HHKB, yeah, this is a new logo. I was tired of the simple like logo with PCB by Cipolot. So I decided to do a more like clean. I'm not sure it's clean, but it's surely more professional looking than the old one. So there's a logo, there's my name, just a bit of clarification that I do PCBs, and my Discord ID numbers. I don't want to do like contact us on Facebook, Instagram, Discord, that kind of thing on PCBs, because at the end of the day, on this PCB I could do that, but if it's a client PCB, for example, the TKL that we worked on, it's a bit of a cock move, I think, to basically do PR stuff on someone else's project, if you know what I mean. When number one, probably never, because I don't want to pay for Nitro. I think it's a meme product, especially the standard plan. There's really no point. You can basically use every emote and animated emote if you try hard enough, or if you wait for Dragon to make it into a GIF, so you can use it everywhere. Yeah, so as I was saying, the problem was again that the shifts, funny joke, key position and function. So I had to give every pad position its own matrix position. So the first one is row 3, column 12. Second one is row 3, column 13. Unified is row 4, column 13. 1.75 again is a row 4, column 14. And the last one is row 3, column 14. You'll see that one entity, it being a column or a row, must be shared simply because the pads collide into each other. So that's how you handle colliding pads, but treating them as separate entities. There are cases where the pads will merge so much that it's not possible to diversify them. One example could be this 3U and 1.5. This configuration is a merge between the split spacebar 3U on the HHKB version and the extra 1.5U needed for the Realforce JIS bottom row. So it's this one. So this is the 1.5, and imagine another pad for the 3U here. So there is really no way around it. Some might say to just cut it in half, but at that point I'm not going to explain it in this stream because it's quite heavy explanation wise. You can simply cut pads, whatever, and pretend that the pad will work. I'll probably do a separate stream, maybe designing and showing how I designed some of these pads. Because, for example, these pads are a single footprint, but in the schematic, they have every pad breaked out to actually accommodate for the various configurations. So, anyway, I digress. So, in this case, the 3U is a spacebar, the 1.5 is a, I think it was the shift key for selecting the suggested options for the hiragana and katakana. or it was a katakana or kana only key. I'm not sure. So there is really no way around it other than basically force the user to manually change it. For example, this uses the PCB that I'm showing on screen, and I shipped the firmware with the JIS option by default, not because I'm a weeb, but because I think that JIS is very underrated. I know that it is underrated simply because people don't use the JIS layout, but the extra keys are actually quite useful if you remap them. Okay, so let's say instead of through HHKB I have 3U. So now this key should be a space, but instead it's a language switch key. It's the Hank key code, and that's because the 1.5 is my default layer option, so the way it's shipped is this one. So as you can see, I have some keys modified here and there, but you get the point. The bottom row is configured to be one-on-one with the real force. So this is the space, it's the 2.5, so it's a good thing that these true space bars are all interconnected, but some keys need to be manually adjusted. Here we are in luck because the spacebar do not collide with the other language switch option key. But again, this one needs to be manually changed. I tried to make it so when you change the layout or you select a various bottom row, basically the key map automatically adapts to it, so you don't have to manually change stuff around. But I didn't find an easy way to do it, or at least not a way that I was happy with. I could ask on the Q&K server or ask directly to XYZ about it, if you can maybe implement a custom VL option, but frankly I don't see the point because people will remap stuff anyway, and shipping it with the JS option by default is just a power move from me, so it is what it is. Oh, one thing that we can see is the ISO. If I loaded the correct, yeah, let's go. So this is the ISO that is Q&K compatible, VL compatible, and we can see that it works. And I have full lighting control. On this specific version, animations are very limited because I have a very long scan routine for EC, so there is very limited space left for all the super duper animations that Q&K supports. Literally an at mega scale issue. But again, I don't want to make it too much over the top using STM. I have an STM version already designed. I could publish it without ordering protos, simply because, I mean, if this mesh works. Mesh, not as in it's badly designed, but mesh with all the custom pads and all of that, it's not going to be a problem with a single key, if you know what I mean. But yeah. So yeah, to wrap it up, now that I know that the EC60 works, I can start to design a TKL, like what the EC87 was supposed to be from the beginning. I wanted it to be the equivalent of the H87/88 for EC. Again, not as in you take it and it will work on every board, but rather as in a reference design that you can take and use if you don't want to mess around with the PCB, or you want a larger PCB for whatever reason, a smaller one, you can do it. Plate wise, again, I will probably do the same approach as the EC60, given the sheer amount of options, especially on the right shift. As I stated in my Discord server, the cutouts are big AF, and if the plate is not on spec, the housing will probably stud around, messing with the alignment. So what I'll do is share a couple of like pre-configured plate options. So for example, for the EC60, I decided to let's see if I can find pictures. Okay. For the EC60, I have the HHKB plate. This is for the standard Topre housing. Again, mainly because it's a reference design, so if the step situation is a problem, you can probably figure it out on the case design or use CoStar, whatever. Again, those are only for reference design. They're not intended to be like the final plate design that you have to use, because otherwise it will not work. Like you can probably even use 1/3 of all the screws that I implemented, and I stated that on my server. The inclusion of that many screw holes was to basically play around. That's it. So I have an HHKB, pure HHKB, a Real Force R191U JIS plate, and I'll do, if I feel like it, a standard 60% ANSI and ISO with the modifiers in the standard configurations. So the one that if you go on KLE, you'll see. This is so slow. Okay, so in the presets, basically. Nice. I think the website is broken. Okay, so for example, this will be the standard 60% ANSI, and the same with ISO. So if you want, for example, split shifts, right shifts, either the 1.751 or 1.75. You'll basically have to do it yourself. There are so many permutations of the plate design that I can't physically account for all of them. Maybe someone wants ISO, but HHKB style split right shift, but for whatever reason, they might want a unified left shift and split backspace. The bottom row, they might like the JIS one because they maybe remap some of the keys to custom macros. So you'll see that when you have that many options, designing a universal PCB, a universal plate is basically impossible given the assembly type of Topper, but also MX. Like in some cases, a universal plate is basically impossible. So I'll provide standard plate designs to give an idea, and then you can play with it. And the same will be done for the eventual EC, whatever I want to call that, TKL, which will extend the 60% to a TKL size. For the Real Force project, I'll not include nor provide plates, again, because the project is intended as a drop-in replacement for existing Real Forces. And if you want a custom plate for whatever reason, then it means that, at least on my point of view, feedback is of course appreciated. You're basically designing an entire board with case, functions, weird stuff, whatever mounting system you want to use that is compatible with Topper. So at that point, you are going to design the plate based on the layout options that you want to implement, and at that point, you can simply design it yourself. But again, because again, there are so many options that I can't include all of them. And the fact that some of the holes are included in some revisions of the board and in others are not, basically increases exponentially the I have to do X amount of versions problem. So that's the main motive behind not doing plates for this kind of design. I think that's pretty much everything for today. Unless there's something that you guys want to know or ask, I think that in about, let's say, 2 minutes, I'd say, we can head out and for the EU folks, go to bed, even though sleep is a mental construct, the same as time zones. So yeah, I'd say 2 minutes for questions or requests, and then we can probably start to look around for people to raid. Let me see if there are any keyboard streamers. I don't have. Oh wait. Oh, okay. I muted myself. Poggers. And the delay is not even that high. Poggers. US is live. Oh, Poggers. Yeah, you know what? We can raid him. I gotta check how to raid because I'm doo-doo. Raid, I think. Okay, raid and channel. Okay, so I should have a raid message. But yeah, of course it's not working. So you know what? Let's come up with a new... Oh, I have it. I have it. I have it. We're gonna use the famous did you heard hello sir, do you have a minute to hear about the good word of EC? And the Church of Rubber Cup Talk. And then let's throw the let's see, a standard emote so that everyone can use it. Let's use party time. Yeah, why not? Yeah, so this is going to be our raid message. And if there are no questions, I'm gonna start the raid command. And we can raid Mr. Lewis, who is still playing Weeb, even though he didn't like it the last time he played it. Yeah, okay. So it was a fun one. I'll probably stream again this week, probably talking about the problems with the multi-layout specifically, and I'll throw some simulations that Papagondo decided to kindly share with me a while ago, since we basically shared some informations about our design process. Alright, so let me copy the raid message again if someone exited chat for whatever reason, and we can start the raid. Raid, there we go, channel. And again, thank you all that joined, and keep an eye out on probably SimonQuad or my Discord server for the next stream. I don't know when it will be, but it will happen. Bye bye.